about to blow your mind by telling you that the answer to this limit problem is not 1. Heck, it's not even -1. And if you're not sure why you're at the right video, let's dive into the answer here. So smash that like button like a ninja and let's get started. When you have a limit problem like this, the first logical thing to do is to take whatever we're approaching for x, being 3 in this case, and just plugging it in. But that doesn't really help us to get the answer yet, because you'll find that you simply will end up with 0 divided by 0. The other challenge here is that we have this absolute value in the denominator, and this happens to give people a lot of problems. And that's why so many people miss these kind of questions with their limits, because when you have an absolute value, the behavior of it changes based on to the left or to the right of where it happens to equal 0. So for a problem like this, I like to think of it as a piecewise function where I'm approaching the problem from the left and from the right of where that absolute value changes. So what I want to do is I want to rewrite this problem such that x is approaching 3 from the left, and we're going to use 3 minus to indicate that. And by left, what I mean is you want to take the value of 3 for x, but go just a smidge to the left. So in other words, values that are just under 3 or less than 3. So for example, you could do 2.99, 2.88, but for simplicity's sake, what I like to first try out with trial and error is whatever that integer value of x is, I just go one less. So in this case, I'll try the value of 2. When you plug in 2 into the function for the absolute value of x, you'll get the absolute value of 3 minus 2, which is 1. But I want you to notice something very important here. Do you notice that if you plug in 2 for x, 2.8, 2.7, I want you to pause the video and think about how you would rewrite the absolute value of 3 minus x for values that are just under 3. Take a moment. Okay, notice that for x is less than 3, whenever you plug in x, you'll notice that the difference of 3 minus x is going to be always positive, right? But then when we take the absolute value, notice that you're taking the absolute value of a positive, which still gives you a positive. So in other words, what we can say then is for x being less than 3, we can actually rewrite this expression of the absolute value of 3 minus x as simply 3 minus x. It's the same thing, right? The absolute value isn't changing the sign. So if you go back to the original limit problem for approaching 3 from the left, it actually becomes 3 minus x over 3 minus x. And we know what this limit is. That's just simply 1. Okay, now let's go ahead and repeat approaching the problem, but this time from the right. So what I'm going to do is I'm going to rewrite the original problem as 3 plus for what x is approaching to indicate that we're going from the right. And now instead of choosing values just to the left of 3, we're going to choose values just to the right. So for example, here for simplicity, if we're approaching 3, I'll just go one more value above that, which will be 4. When you plug in 4, you'll notice that the absolute value of 3 minus 4 is the absolute value of -1, which of course, when you take the absolute value, gives you +1. So think about how you would actually rewrite the absolute value of 3 minus x in this case. It's a little trickier, not too bad, but pause the video and think about what you can rewrite it as without using the absolute value function itself. Okay, notice that for 3 minus x, whenever you plug in a value of x that's greater than 3, 3 minus x is going to be negative, right? So 3 minus 5 is -2, 3 minus 4.5 is negative, and so forth. And then when you take the absolute value, you are flipping the sign. So in other words, you're basically multiplying the expression by a -1, right? So what we can do then is for x being greater than 3, we can rewrite this absolute value expression of the absolute value of 3 minus x as being the same as -1 times 3 minus x. And if you don't believe me, just plug in some sample values of x that are just greater than 3. I like to do that with trial and error too, just to help me visualize. And when you go back to the original limit, where you're approaching x just from the right of 3, which is going to be 3 plus, that 3 minus x divided by the absolute value of 3 minus x then can be rewritten as the limit as x approaches 3 from the right of 3 minus x over, from what we got above, -1 times 3 minus x. Now with this, the 3 minus x terms cancel, and you're going to be left with a limit answer of -1, but there's a kind of a problem here, right? Because if we summarize, Notice that when we approached 3 from the left, we got a limit of 1. And when we approached it from the right, we got a limit of -1. What do you think that means the answer is? Okay, so we have a bit of jump discontinuity here. So in this case, this simply means the limit does not exist.